Good afternoon, everyone. Myself Reshma, working as an assistant professor at Riper Autonomous. Today, I am going to explain about the beta oxidation of fatty acid. So, first, let us know what it means. So, beta oxidation of fatty acids is defined as a catabolic pathway for breaking down of the fatty acids at the beta position to produce the energy in the form of the ATP. So this process is going to be occurred in the mitochondria during the period of the fasting, starvation or uncontrolled diabetes. So it is going to be occurred in the three different stages. They are, first stage is called as the activation of fatty acids. Second stage is called as the transport of activated fatty acid, and the third stage is called as the beta oxidation of the fatty acids. So we come to know in detail about the each stage. Is activation of fatty acid. In this stage, the fatty acid is going to be converted as the acyl CoA with the help of the enzyme acyl CoA synthetase enzyme. So the enzyme is also known as the thiokinase enzyme. So during this reaction, it requires ATP, magnesium and one coenzyme. So the ATP will be converted as the AMP and pyrophosphate. So the pyrophosphate further it will be hydrolyzed to form the inorganic phosphate. So the inorganic, whatever the energy produced during the hydrolysis of pyrophosphate will be helpful for this reaction, and the activated form of fatty acid acyl CoA will be enter into the stage 2 of the beta oxidation of fatty acids. Next we will see the stage 2 of the beta oxidation of fatty acid, where the activated fatty acid is going to be transported into the mitochondrial matrix. So acyl CoA is a large molecule, so it requires more energy to cross the membrane. So here the coenzyme is going to be replaced with the carnitine molecule, which is a small molecule and it requires the less energy. So here the acyl CoA will be converted as the acyl carnitine with the help of the carnitine acyl transferase 1 enzyme. Then these acyl carnitine will easily crosses the mitochondrial membrane and it will enter into the mitochondrial matrix as acyl carnitine. And in the mitochondrial matrix, the acyl carnitine will get separated as the carnitine and the acyl CoA by the attachment of coenzyme with the help of the enzyme carnitine acyl transferase 2, and the acyl CoA will enter into the stage 3 and the carnitine will get returned back into the cytosol. The transported fatty acid will enter into the stage 3 of the beta oxidation, where the activated fatty acid will further degraded in repeated sequence of 4 reactions. Those reactions are called as the dehydrogenase with respect to the FAD, and second step is hydration, and the third step is again dehydrogenase with respect to NAD, and the fourth step is called as the cleavage. So let us see the each step in detail. So the first step is dehydrogenase in respect to FAD. So here the fatty acyl CoA compound will get release the hydrogens at the beta position, which leads to the compound unsaturated, and FAD is going to be reduced as the FADH2. So these FADH2 further enter into the electron transport chain to produce 1.5 ATPs. So the reaction is going to be occurred with the help of the acyl CoA dehydrogenase enzyme, which results in the formation of the compound alpha comma beta unsaturated fatty acyl CoA compound. Then this compound is going to be enter into the second step, that is hydration, where the compound is going to be hydrated at the beta position with the help of the enzyme enzyl CoA hydratase enzyme, so which results in the formation of the beta hydroxy fatty acyl CoA. So at the beta position, hydroxyl group is going to be present. In the next step, again it is going to be dehydrogenated in respective to the NAD. So with the help of the enzyme beta hydroxy acyl CoA dehydrogenase. So the process is dehydrogenase and the substrate compound is beta hydroxy fatty acyl CoA. So based on that, enzyme name is given as the beta hydroxy acyl CoA dehydrogenase. So here it is going to be remove the hydrogens to form the ketone group here at the beta position. The released hydrogens are going to be reduced by the NAD, which will result in the formation of NADH plus H. and it results in the formation of compound beta keto fatty acyl CoA compound. In the fourth step, that is the cleavage, the compound is going to be breakdown at the position with the help of the enzyme thiolase and the addition of coenzyme to form acyl CoA and acetyl CoA. So the formed acetyl CoA will further enter into the TCA cycle to produce the ATPs. So each beta oxidation is going to produce one molecule of the FADH2 and one molecule of the NADH plus H plus and one molecule of the acetyl CoA, which means if the we'll take the example for the beta oxidation of fatty acid as palmitoyl CoA. So palmitoyl CoA is a 16 number carbon chain, so which gives the 7 slits of the cycle and 8 compounds, so which results in the formation of the 7 NADH, 7 FADH2 and 8 acetyl CoA compound. So this is the representation of the beta oxidation of the palmitoyl CoA, where it is giving the 7 cycles. So now coming to the energy calculation of the palmitoyl CoA. So each acetyl CoA is equals to the 10 ATPs and one NADH is equals to the 2.5 ATPs and one FADH is equals to the 1.5 ATPs. So we multiplied with the cycle we multiplied with the number of ATPs. So 8 into 10 ATPs and 7 into 2.5 17.5 and 7 into 1.5 is equals to 10.5, so which results in the total of 108 ATPs. So the gross ATPs produced from the beta oxidation of palmitoyl CoA is 108 ATPs, and these 108 ATPs we are going to minus the 2 ATPs which we are utilized in the stage 1 for the activation of the fatty acids. So the net of the ATPs are 106 ATPs. So this is about the beta oxidation of the fatty acids. I hope you understood. Thank you.